Hello everyone, my name is Donavan. I'm one of the team members of Group 11 of Class EEL 4920 Senior Design. And I'm going to go ahead and get us started off on a conversation of globalization and its importance. Most importantly, why for our project we're focusing on worldwide adoption and our ability to cross overseas and breach the water barrier into international markets. Um, as you can see here, our project is focusing on the capability to cross markets for sake of the betterment of the everyday lives of people across the globe and cultural impact. And to do so, we're going to be focusing on following the criteria set in place by the World Trade Organization and the International Organization of Standardization. Here I want to talk about our international focus and cultural capability to have conversation with overseas markets. For example, I bring up Jacob and Armani, cultural and exchange students that we have been in contact with and have given us good feedback on our design and our ability to permeate the markets of Honduras and Britain, for example. I want to talk about next about our standards consideration and how we have been focusing primarily on those set in place by the Institute of Electrical and Electronic Engineers, these three in particular. The first of which being one based on reliability for development and production of systems. The next being a framework for reliability prediction, and the last being recommended practices, all set in motion for sake of reliability, for safety, and for general use case of repeatability of the end user.
Hello, I'm Nicolle, and I will be presenting the feasibility analysis and risk analysis of our project idea of the smart lock system. Feasibility analysis is a crucial step in project planning, aiming to assess the practical and potential success of project proposed. This analysis involves a thorough examination of every factor to determine if the project is achievable and worth pursuing. By conducting a feasibility analysis of a project, its probability of success can be measured by a standard score. The assessment involves evaluating a various types of feasibility, such as technical feasibility, economic feasibility, legal feasibility, resources feasibility, and marketing feasibility. Each type of feasibility is assessed and an average score is assigned based on all its attributes. It is also essential to determine the weight of each kind of feasibility, which indicate its importance for the project. Finally, the score and weight of each type of feasibility are used to calculate a weighted average that determines the project feasibility. If the weighted average is above 3.0, the project is then feasible. Technical feasibility. For the technical feasibility, our team calculated a total average of 4.5 after analyzing all the factors that this feasibility assessed. For economic feasibility, our average total calculated was also a 4.5 within the two factors that we took in consideration. For the legal feasibility, our total average was a 4.0. For the resource feasibility, our calculated weighted average was 4.5. And for the marketing feasibility, was a 4.33 after analyzing the three attributes that we took in consideration. Now, risk analysis. It is important to conduct a risk analysis before creating our auto lock door system. This analysis considers factors like cultural concern and technological obstacle to anticipate and listen potential obstacle. We will be diving into each of the categories from integration to the legal dispute to ensure throughout our project risk management. This diagram illustrates each one of the categories that we identify potential risks, such as resources, technical, schedule, economic, marketing, and legal potential issues. After analyzing each one of the potential categories about our smart lock, our team identified a total of 8 risks that could prevent us from completing our project in the expected time. However, alongside this 8 techniques for resolution, our team have developed a plan of actions with also alternative solutions that should take care of this potential risk factor and allow us to complete our project on time.
Our team is very committed to completing our project and fulfilling all of our original objectives. And we know that while we do that, it is very important that we stay on task and keep our project moving very efficiently. And that is why we've created this very detailed and specific plan of action to keep all of our team members on the same page, knowing exactly what tasks they should be doing and what tasks they should be doing next. Through our plan of action here today, you'll see that we have clearly defined team roles, we have our milestones with expected completion dates, we have our work breakdown structure, and we show our scheduling through PER charts and Gantt charts. Here you can see our clearly defined team roles. These are team roles that were determined to best use each team member's ability and what they could bring to the team. For part 1, our milestones are listed here with our expected completion dates. This is our work breakdown structure. The work breakdown structure shows that our smart lock breaks down into 3 main parts of the smart lock with the percentage of the work they are expected to entail. The first part being the lock hardware, the second being the smart unlock peripherals, and the third being the app. And each section breaks down into smaller tasks that are the deliverables for our project and the things needed to be completed to finish that step. The PER chart is a very useful chart for keeping our team on schedule. It shows each task that needs to be completed, the estimated amount of time that each task should take, and it also shows which tasks can be completed simultaneously and which ones need to be done sequentially, so nothing gets out of order and the whole team can stay on schedule. The Gantt chart is a very detailed breakdown of who is going to be doing each task, which one should be done first in the order, and which ones can be done at the same time, whereas which ones need to be completed in order to move on to the next phase.
Hello, my name is Yamileth and welcome to my portion of the video. For presentation 2, I'll be talking about multidisciplinary aspects. The multidisciplinary aspects is basically an overview of the hard work that we put into it, meaning the hours, the team members, and our experience that we've had over the years with engineering classes, internships, workforces, and the budget. Teamwork. So each of us are pursuing a specific bachelor's degree in engineering, but we have an even more specific expertise. So Donavan is pursuing computer engineering and his expertise is hardware. Brian is computer engineering as well and his expertise is software. Myself, I'm pursuing computer engineering and my expertise is hardware. Nicolle is pursuing electrical engineering and her expertise is software and peripheral engineering. And Ledwin is pursuing computer engineering with an expertise in app development. So Ledwin, he is our team lead. Again, he is pursuing a bachelor's degree in computer engineering. His expertise is application development. His strong suit languages would be Java, C, and C++. He has experience in both customer service and application development. He has 2 years of customer service, which really helps in leadership and support to our team. Application development, his expertise there will help us with the development of the actual app. Nicolle, she is pursuing a degree in her bachelor's of electrical engineering. Her expertise are software and peripheral engineering. Her expertise in C++ help her with the reliability, performance, efficiency, and safety of the electrical systems. Her skills are the electrical engineering, maintenance, and operations. She's been doing that for a little over 4 months, and she brings a lot to the table as an administrative assistant in order to keep management and control of our team and our work. Brian Paquette is pursuing a bachelor's degree in computer engineering. His expertise is software engineering. He performs diagnosis of vehicle, both electronic and mechanical issues. He also performs and or assists in these recommended repairs on the vehicle that he just diagnosed. His experience is mechanical and automotive technician for a little over 5 years, as well as a Honda technician, meaning the starting off just performing diagnosis, but he did level up, and this can help us specifically in both the software and hardware aspect of our product. I am pursuing a bachelor's degree in computer engineering. I have an expertise in hardware engineering. I consistently perform maintenance of hardware devices in my job as a help desk technician. I have been working here at Monat Tech for a little over a year, and I do have a 5+ year experience of customer service and management. Donavan is pursuing a bachelor's degree in computer engineering. His expertise is hardware engineering. He performs maintenance to servers, both software and hardware side. He has customer service and computer engineering internship. So on to our budgeting and our hours. Each of us had to complete a certain amount of hours in order to get through this project and make sure that everything was done properly. We divided those specifically, and the total amount of hours between all of us would be 475.2 hours. As for the costs and the budgeting, we have a list here shown of the assets, meaning which topics would be costing how much. So for research, it would be 660. For the unlocked peripherals, it would be 1,008. For the application, it will be 1,250. For the lock hardware, it will be 1,830. For the lock finalization, it will be 2,738. And as for a total, it'll be 74,800. Thank you.
Hello, my name is Nicolle, and I'm going to talk to you about the end product descriptions and functions. So basically, I'm going to give you more information on how our smart lock works. I'm going to tell you how the different inputs and outputs interact together and with the microcontroller, because I'm sure if you know how something works, you're going to feel comfortable and, more importantly, safe when you're using it. We want to give all the information to our customers, and we have nothing to hide. Moving forward to the level 0, here's the basic diagram that shows how the different inputs and outputs interact with the microcontroller, in our case the Raspberry Pi 4. And basic diagrams, just listing the inputs, the outputs, and the functionality. So we have inputs, keypad, Bluetooth, smartphone, or the internet. And the output, we have the servo motor, the smartphone, or the internet, and the power supply. The functionality basically says we have a smart lock that has 3 different ways to be unlocked. In case one of them doesn't work, it shouldn't happen, you always has a backup. Moving forward with our level 1, something I didn't mention before is that we need a 5-volt to power our servo motor. In this case, that power supply is offered by the microcontroller, so there is no need to have any external power supply. Here we have a more detailed chart. So we have the different inputs, the keypad, entering personalized pin codes, the Bluetooth, proximity-based unlocked. The smartphone is to remote control and as well check the status of the smart lock through the phone. The output, we have the servo motor, control the physical locking mechanism. We have the smartphone, send notifications and receives data. And yeah, basically that's all we're going to have here. As well, we have other resources like video presentations, storyboards, and final reports. I'm hoping that this information, gives you a clear idea how the smart lock works, and probably just ensure that you will be using one of the best smart locks in the market. Thank you so much.